each. So when we think of a translation, translation means to move or to slide over. Reflection means to do what? Reflect, you're right. What other word can we connect with the word reflect? Flip. What does it mean to rotate? What? To move, but it's not just like moving over, it's turning, yeah. So rotation means to turn. Okay, so if you want to try and sneak that up above here, this is the definition. Turn an object around a point. So for example, the Earth rotates. What is the point that the Earth rotates around? Yep, the sun. Okay? So the whole time that we rotate around the sun, the Earth is staying the same distance from the sun. There's not one point where all of a sudden we're like an extra 500 light years away, right? Okay, so as we rotate, we want to stay the same distance around that. All right, we're going to talk about this word clockwise and counterclockwise because we're going to see that. And clockwise and counterclockwise has to do with the clock. And the amount of times that people have a tough time reading a clock is rough. You don't have to know how to read a clock in order to know clockwise and counterclockwise. Okay, so if you still are struggling with like what this time is showing, what time is this showing? Close. Why is it 1:50?
6:07.
Yeah, it's almost to the 2. If it was 2:50, it would be almost to the 3. So 1:50, and what's the second hand at? How many seconds? 45. Good. All right, so we're going to be doing clockwise and counterclockwise. So clockwise, I'm going to highlight that. Which way is clockwise? Which way does the clock work? Okay, the clock, where do the hands start? At what number? 12, and then which way does it go?
Right.
Yeah, right. It goes to the 1, 2, 3. So clockwise is moving down to the right. I'm using 2, so if you want to grab 2, you can. All right, then we have counterclockwise. Okay, counter, or in some cultures, if you go to like the Asian cultures, instead of using the word counterclockwise, they use the word anti-clockwise. Counter and anti are the same prefix. What does counter mean? Yeah, to go like the opposite way. So counterclockwise means we start at the 12 and we're going to go to the left. Okay, so I'm just going to use some colors just to kind of show the difference between clockwise and counterclockwise today. All right, over here in this space, we're going to create a rotation and talk about the kind of the 4 main directions that we do. So to start off with, we have R. I'm going to do that capital R. And this is going to be our starting point for this one. This would be 0 degrees. Okay, now I'm going to rotate it. And as I rotate, if I go this direction, I'm actually going to take my book. I'm going to zoom out for a second. I'm going to take my book and I'm going to rotate my book. Now I'm going to draw an R here. So if you want to rotate your book and draw an R. Okay, then we're going to rotate again. So I'm going to flip my book completely upside down. Do an R. And then rotate one last time. So flip the book again. And then it would rotate and be back to the top. Okay, so I actually, when I do this one with the R's, I actually do rotate my page. So now as we look at it, you can see that R is turning. Okay, the curve is always kind of on this right side, and then as it moves, it's now at the bottom. As it goes down, it's now on the left side, and then as it goes on the top, it's on the top. If I look at the 0 degrees and the one halfway, is this a reflection as it flips upside down? Did it flip completely, or did it turn? It turns. This is not a reflection. Okay, some people, when they do that 180, they think it should look like a reflection, but remember, it's just turning around. Okay, so this is 0 degrees. With the way I drew my arrows, did I draw my arrows clockwise or counterclockwise? Good, I did clockwise, which is why, I don't know, in our world we do things clockwise most of the time, but for rotations in the math world, we do counterclockwise. So let's start with clockwise for a moment. If I go to this degree, how many degrees did that turn when we rotated our book? We rotated it a quarter, so a quarter is 90 degrees. So I'm going to say 90 degrees clockwise. I'm going to say CW for clockwise. And then I'm going to use that color I used for clockwise. Okay, then I rotated it again. So how much total would it have been rotated from the beginning to here when it flips halfway around? 180. Again, I'm going to put that CW for clockwise because I'm still going in that direction. Okay, then I go 90 degrees more. How much is 90 degrees more than 180? 270, good. And again, I'm going to put that CW for clockwise. Got a little crunched there, that's okay. Okay, and then if I end back at 0 degrees is the same as how much if I go all the way around? 360. Okay, or we could keep adding on to that. It could be the same as 720 or 5840. Okay, nope, not 540. 540 would be at the 180. Anyways, so as we keep working around, we could keep adding and adding, but these are kind of our cardinal directions as we work. Now, depending on where we started, these would change. So if I would have started with this R, that would be 0 degrees, then this would be 90, 180, 270. Okay. All right, but we're also going to go the other direction, so I'm going to add in those arrows in the other direction here. But let's talk about that if we went counterclockwise. So if this was 0 degrees at the top, and I went counterclockwise, I went to the left, I would now be at this one. And this one would be how many degrees from here to here? If I go this way. Yeah, 90. So now this is only 90 degrees. I'm going to go CCW for counterclockwise. And I'm going to highlight with that color that I went the other direction with. Okay, at the bottom, how much would that be from the top to the bottom? If I go this direction. Yeah, it's still 180. So no matter what, if you go counterclockwise or clockwise, the 180 still lines up. That's like the 6 o'clock. 6 o'clock, doesn't matter which way you go, you still end up at the 6. You're halfway around. Okay. Then if I keep going counterclockwise, I go another 90 degrees. How much would this one be over here? 270. All right, how are we feeling? Kind of making sense a little bit? We're visualizing it? All right, so a lot of times in your problems, we're going to be using the word counterclockwise. I don't know why, like if we all know clockwise, why wouldn't we continue to just do clockwise? But I don't know. In the world, they just like to use counterclockwise. All All right, so we're going to learn there's different rules. Some people are really good at visual. So if you ever have Mr. Veroniak can do this without writing this down. And I just look at him like in awe because I'm like, I can't do that. But there's things I can do that Mr. Veroniak can't do either. So it's okay. We all have our strengths. So some people are really good at just being able to visualize how this is going to change. But I always have to follow rules. That's the way that my brain works for these ones. Okay, so we're doing 90 degrees counterclockwise. So I'm going to do that 90 degrees counterclockwise is my rule. What would be the same as 90 degrees counterclockwise, though? Good, 270 clockwise. Because that's at the same spot. So we're doing 90 degrees counterclockwise, or you can think of it as 270 clockwise. Now what's nice about our graphs is they're broken up into 4 spaces already. So as we think 90 degrees counterclockwise, we're going to move to the left. So X right now is in quadrant 1. If it moves left and around, which quadrant is it going to end up? If it only moves over 90, it's only going to move over 1 quadrant. Is it going to move to quadrant 2 or quadrant 4? Yeah, quadrant 2. Okay, the X, or what is that? That's a Y. Y is on the X-axis. What's 90 degrees rotated from the X-axis? The Y-axis. Yep, so all of this is going to get moved over. We're rotating that around this way, 90 degrees. And it's about the origin, which just means that we want to make sure that all of our spaces from the origin stay about the same. All right, so our rule, like I said, some people, they can visually just do this. There's probably people that are visualizing in their head and they got it. That's great. Not one of my strengths. I always follow the rules. For the first rule, it's XY is going to change, and when it changes, it's going to be opposite of Y, and then X. Okay, so that rule is really important. If you're not taking notes today, but this is like something you want to write down. All right, so we're going to go through and we're going to change this. I already wrote down the ordered pairs for what this one is. Okay, we have W prime. Now remember in our ordered pairs, it always goes X, Y. So I want to start with Y and the opposite of Y. So which number is my Y? 1. It's the second one. And what's the opposite of 1? -1. And then I want the X. What is the X? 1. That one was a little confusing because they were the same number, but we'll get there. All right, X prime. So as I do X prime, I want to start with the opposite of the Y. So which number is my Y? 3. What's the opposite of 3? -3. And then my X? 2. Okay, Y prime. Start with my Y, which is which number? 0. What's the opposite of 0? 0. And then just keep the X, 5. Okay, Z prime. Want to start with my Y. What is my Y? -1. What's the opposite of -1? 1. And then my X? 3. So we use that rule to create these points. Once these points are created, now I'm just going to graph those points like normal. Okay, so -1, 1 would be left 1, up 1. So from the origin, left 1, up 1. Here's W prime. -3, 2, so left 3, up 2. Okay, and there's X prime. Okay, Y prime is 0, 5. On rotations, usually this is the one that gets people because they don't know where 0, 5 is. Is 0, 5 going to be located on the x-axis or the y-axis? X, good. So 0, 5 is just up 5. Okay, and then z is 1, 3. So right 1, up 3. Okay, and then if you have that straight edge, you can use a ruler from your bin or the side of a piece of paper. Okay, so then that's that rotation. It rotated around 90 degrees. Okay, or we could have gone the other direction, and in the other direction it rotated it 270 degrees. Really with quadrants, what you want to think is how many quadrants are we moving? With 90 degrees, if that's what's telling us is our cardinal direction, the amount we're moving, we want to move over one quadrant. Okay, I left the graph on the board up there on purpose so that we can see that x moves from quadrant 1 over to quadrant 2. All right, next up we have a rotation of 180 degrees about the origin. So how many quadrants would we move if we're moving 180? 2, yeah, because one quadrant would be 90, so 2 quadrants would be 180. So y is starting in quadrant 3, so where is it going to end up after we do the rotation? Just the one next to it for 180? 1, 2. Yeah, it's going to end up in quadrant 1. X and W are in quadrant 2, so where are those going to end up? Yep, quadrant 3. Sorry, quadrant 4. Good. Okay, so for our 180 degree rule, this one is one that I can do without having to write it down. The 180 to me makes sense. Okay, and 180 is the same clockwise as it is counterclockwise. If I remember correctly, in ALEKS, they do both, so you have to make sure that you're looking and reading the directions. Okay, this is both clockwise and counterclockwise. It's the same rule because 180 doesn't matter which way you go. Okay, XY is going to change by saying opposite X, opposite Y. So we don't change the order the numbers are in, we just change the signs. If it's positive, it's now negative. If it's negative, it's positive. All right, so for W prime, we had negative 1, 1. So what's the opposite of negative 1? 1. Opposite of positive 1? Negative 1. I'll help you in a second, dear. All right, opposite of negative 2. 2. Opposite of positive 3. Negative 3. Opposite of negative 4. 4. Opposite of negative 2. Positive 2. So we didn't change the order. If 2 was first, 2 is still first. It just changes the sign, positives to negatives. All right, once we have this new set, we can now graph that on our graph. So in ALEKS today, if you're rotating an object, you might want to take a whiteboard out and write down the ordered pairs and then write down the new ordered pairs. You have to do this work kind of on your own. Okay, on ALEKS, it'll only show the graph. And again, on ALEKS, I can't just go straight to the graph. That's not something my brain takes me a lot of work. All right, so 1, negative 1 would be right 1, down 1. 2, negative 3, so right 2, down 3. And 4, 2, so right 4, up 2. Alright, I always like to use a straight edge when I'm drawing it by hand because that helps me see if the shapes look the same. Remember, we're not changing the size. It should be about the same size. It should just look like it rotated around. All right, last one. You guys are crushing this. I know the notes are a little long today. You guys are doing really good. This time we're doing that 270 degrees around. So 270 is 3 around. Okay, and we're going counterclockwise. So 270 degrees counterclockwise is the same as what clockwise? 90. So this is going to be our 270 degrees counterclockwise or our 90 degrees clockwise. Okay, if you're not taking very good notes today, writing down these rules is going to be really important. All right, this time x, y, it's going to change the order. It's going to be y, x, but the part that changes is the x. It's going to be opposite x. So y, opposite x. Now, I'm going to show you how I do this. My brain works different. If you want to keep working point by point by point, and that's been working for you, keep doing that. Okay? For me, when I do this, I like to do it number by number, and I actually go through all the points at once. So I'm going to do x prime, y prime, z prime, and I put in this parenthesis, just showing you how my brain works. And some of you are going to look at this and be like, dude, she's nuts. And some of you are going to be like, oh, this makes sense. All right, starting with y. So I'm going to cover up the x's. Am I going to change the y or just keep the y? Just keep it. So I'm just writing these numbers, -2, 1, -3. I'm just writing those y's, those second numbers. All right, then I have to do opposite of x. So I'm going to cover up my y's, and I want to just do the opposite of those numbers. So opposite of 4, -4, opposite of 3, and then opposite of 3, -3. Then put in those parentheses. That's why my brain works, because it's really hard for me to start that process every time. Like, okay, which one am I starting with? Am I starting with X or Y? Okay, I'm starting with Y. Is it same or different? Same. Does that make sense a little bit? So that's why my brain works, is so that I can just kind of do one thing at a time, and now all of them are done at once. All right, so we have -2, -4. So we're going to go left 2. -4 means down 4. One -3 would be right 1, down 3. Come here. You need this for the notes today. And I'll give you the ones from yesterday too. Z prime is -3, -3. So left 3, down 3. Nothing. We're not talking right now. All right, and then go ahead and connect those points. All right, so remember, we can think about it. It's either 270 degrees counterclockwise, so it moved 3 quadrants over. So y was in quadrant 1. So now it's going to be in quadrant 1, 2, 3, quadrant 4. Or you can think it's 1 clockwise. We're going in the opposite direction. Oh, I bet that's why. Interesting. Never mind. Interesting. All right, so when you do your ALEKS today, double check if it's saying counterclockwise or clockwise. That's going to be a big part. On ALEKS, there's a couple where they don't give you shapes. They're going to give you a line. With the line, you want to draw the end points. So find the end, the beginning, and the end. And again, it might be helpful to write it down so you can follow the rule. Okay? That's the way I do it.